Okay, so this is DeepRiser version 4. So the normal way of viewing results within DeepRiser is when you run a particular analysis, you switch over to the results view, and you can see your normal results from the analysis. Okay, so the main results you're going to look at is going to be the summary report file. Okay, so if I open the summary report file, okay, you can see a summary of all the most important results from your various locases that you've ran. So in this particular case, we've ran 2 locases. Okay, and you can see your main results. So for locase 1, you can see your effective tension, the minimum effective tension, the maximum von Mises stress, maximum wellhead bending moment, dynamic stress range, your various casing bending stresses and moments, telescopic joint stroke data, and then your flex joint angles and moon pool clearance. So this is your summary data. And then for each locase, you get an individual folder where you can view more detailed output from the analysis. So again, you can request additional plots here. So you should be quite familiar with this means of viewing results from within DeepRiser. Okay, so all the same information can now also be seen through the new OptiView module. Okay, so instead of opening the summary report file or the analysis report file, you can click on this OptiView button, which is on the home tab of the DeepRiser main window. Okay, so after you've run your analysis, you simply click on the OptiView button to open OptiView. Okay, so there's 2 tabs in OptiView that you're going to see in the search pane. The first one is the search tab, which allows you to look at individual locases or to select which locases you want to view data from. So you can parse the various locases based on a number of criteria such as vessel offsets, waves, currents, and winds. So in this particular example, I've only got 2 locases where I varied the mud weight. Okay, so again, if I see under the mud weight column here, I can see the 2 mud weights that I've included. So if I only want to consider locases with 12.8 ppg mud, I simply select the other one, and then it removes that locase from the window below. So when I switch over to the results tab, it's going to show me the results from all the locases that are displayed in this window. Okay, by selecting everything, you'll see all the locases and the results will be superimposed. So it's very easy to parse the results for each individual locases so that you're only seeing the data relating to what you want to see. Okay, so once you've selected which locases you're interested in viewing, you simply click on the results tab. Okay, and when you see over on the results tab here, we've got 4 radio buttons at the top. Okay, so we're going to go through each of these separately, but I'm going to start with just the custom, which is the default one that's going to be selected. Okay, this is a means of viewing the results, or viewing the plots that were in the default analysis report file within DeepRiser. Okay, so it's going to show you the same plots that you've seen before. Okay, so you can see a list of all the various plots that will be in the analysis report file. And again, if you request additional data using custom post-processing, all the additional plots will be included in here as well. Okay, so if I look at an envelope of effective tension, for example, I simply click on which plot I want to see, and then I click the button Generate Plot. Okay, so when I do that, I see the same plot that I saw in the analysis report file, except now it's superimposed locase 1 and locase 2 together. Okay, and that's because on the search tab, I had selected 2 locases here. Again, if I select only 1 locase and update the plot, there you can see only one locase is now included. So again, you're seeing your minimum and your maximum effective tension for that particular locase. Okay, and again, if I turn it on and generate my plot again, I'll see both locases here. Okay, now again, I can parse these locases individually myself. Again, if I want to just quickly turn off the minimum effective tension, so I'm only seeing the maximum effective tension, again, I can very quickly parse that to show only the information that I want to see on screen. So again, it's essentially the same plot that we've seen in the analysis report file, except it's more dynamic. It's much easier to superimpose various locases, and it's much easier to turn on and off different plots as you want within the graph. Okay. Let me just show you some other features on the OptiView interface. So again, it's just a much nicer interface for actually viewing and interrogating the results. So again, I can simply zoom in and out on the plot on any particular area. Okay, some of these buttons up here, for example, You can export to CSV if you want to do something like that. So if you want to export the raw data to a CSV file, you can do that. You can save the plot. You can make a copy of the plot. You can change the axis of the plot, or you can also change the. So again, for example, if I want the effective tension to be on my vertical axis, I simply change that around. Okay, so I can swap it very easily. I can toggle a legends on and off. So this legend down here, I can turn it on and off as well. So again, it's just more interactive, and I can also move the location of the legend. So I can change how the plot generally looks. I can superimpose the legend. So again, just very easy to configure the plot the way you want to see it. So a lot of other kind of things I can change in terms of color coding. I can add in different series and stuff like that. So again, this allows me to edit the actual data series. So again, I can remove different ones if I want to. I can change the color associated with each line. So for example, this minimum effective tension uses navy. I can simply change it to blue or whatever color I want. If I want to specify a certain limit, I can actually add in additional limits, so that if I put in a limiting line here, it will add in the line. So in this case, if I put in, say, 4,000, sorry, if I put in the limit value of 4,000, and let's say that's my distance, again, I can specify a different line and set it to be dashed. It will then include the line up to that point and give you the corresponding effective tension at that location. Okay, so again, it's very easy to configure it, to add in different limits. You can simply remove the limit if you want as well and change the various colors. Okay, I can also change the titles very easily. So I can change the title and also the titles on the various axes. I can turn on and off the grid. I can turn on the actual data points as well. So if you want to zoom in on a particular point, you can see the various data. I can use cubic spline interpolation. I can also set the range of the axis as well. Okay, so I can set the scale for the x-axis or the y-axis, whatever I want. So I can zoom in on a particular part of the plot as I want. So again, it's very, very configurable. You can also then export the image. Okay, so if you want to save it to a report file, copy the clipboard. It's very easy to do that. And finally, you can add in some additional series as well. If I want to add in a new series on top of what's in the report file, I can simply paste in that extra data there. Okay, and you can also see down here on the bottom, you have the actual raw data that makes up the plot. So again, very easy to copy that data if you want to see, or just interrogate it in more detail. So this is how you'd see the normal plots that you see in the ARP file. Again, hopefully you can see that it's much clearer, much more interactive than the previous report files. The summary report file data is also available here. So if I want to look at my low case summary, I can look at my results. So I can look at my various tables. So again, this is the same tables that we saw before in the summary report file. So again, if I want to see the stresses on the riser, again, I can see for low case 1 and low case 2, I can see the effective tension on stress, wellhead, bending moment, etc. Same with the flexure and angles. So again, it's a more interactive means of seeing the same results that you saw before OptiView was introduced in the first place. So that's really just a starting point of OptiView, and that it can show you the results that you've already got before in the older means of doing it. Okay. The next thing I'm going to show you is the drift-off analysis. Okay, so drift-off analysis, again, a similar type of analysis, it's similar type of results in that you get your summary report file and you get analysis report files. Now, instead of, again, you can use the old method of doing it, where again we open the summary report file, or in the low case folder, you can open your analysis report file and you'll get some plots like this. Okay, where again various parameters plotted against time. Okay, so if I launch OptiView, again, you don't need to launch OptiView. You can switch the analysis by simply selecting up here on the ribbon control. You can select which analysis you want to view. Again, if you have multiple low cases, you can parse the various low cases to say which ones you want to see. So in this particular case, I've only got one drift-off analysis low case, and again, it's shown here. So again, I switch over to my results tab, and again, on my custom tab, I can see all the various results that I could see in the analysis report file. Okay, and there's a few additional, using the powers of OptiView, we can include some additional graphics as well, some different graphical outputs. Okay, so I'll show you some examples of that. So you can see your environmental indicators. Okay, so again, that's just a nice schematic kind of showing you the position of the vessel and the direction of the environment. Okay, so you can see the environmental indicator, and you can see your wind, wave, and current are all acting in the same direction. Okay, we can also see the force indicators. So again, this is a good sanity check in case there's any issues with the coefficient data that you use. Again, you can visually see that the forces acting on the vessel are in the expected direction. Same kind of plots that we saw before, like distance from DP set down. So again, distance versus time. So this would be the same plot you've seen in the analysis report file. And again, percentage water depth distance from DP set down. And this is a new one, this drift off path versus time. So if we take a look at that, it gives you a nice kind of plan view of the vessel and the watch circles. Okay, so it gives you your drift off path, and it gives you your various watch circles. So this would be your point of disconnect, your red watch circle, and yellow watch circle. Okay, so again, it's showing you the raw data, and it makes up the drift off path as well. So again, all the same kind of plots that you could see before are still visible here. So again, very easy mechanism to kind of extract and view the results. And again, it's very configurable in terms of that you can change various parameters, you can zoom in, you can add new series as whatever it is that you want to do. Okay, so the next section I'm going to look at is I'm going to look a bit more detail of how to utilize, say, the parameter utilization and the envelope plots. Okay, so before I do that, I'm just going to show you some capabilities of how you actually do an operability analysis within DeepRiser. Okay, so again, using example 1, we have a folder called Operability, where we've set up a number of parameter study analysis, where we varied a number of parameters, such as vessel offset. In this case, it's vessel offset and its current. Okay, so you can see in a parameter study analysis, you're probably familiar with this already. You can change a number of parameters very quickly to run off a lot of low cases. So you can vary top tension, you can vary vessel offset, and you can vary mud weight. So in this particular case, all we've done is we've varied the vessel offset. So we've gone from, as you can see here, minus 10% up to plus 10% water depth. Okay, so in increments of 1%. So we've set up about 21, each one of these analyses is 21 low cases because we've defined 21 different parameters here. Okay, and then in these 5 parameter study analysis, we've just changed the environment where we've changed from 0% current up 25%, 50%, 75, and 100% current. Okay, so all we're doing with each one of these is we're increasing the current. So we basically have about 21 low cases in each parameter study analysis, and you've got about 5 low cases. Okay, so you've got about 105 low cases in total. So what we can do is, in order to create an operability envelope where we combine the results from multiple analysis, now these can be parameter study analysis or they can be standard analysis, it works the same way. What we basically have is a WSOC component. Okay, so it's well-specific operating criteria. And all this component does is it allows you to group together the various analyses that make up this well-specific operating criteria. So you can simply select your analysis. So we select parameter study analysis, and you can simply select what analysis you want to include. Okay, so you can see I've added in the 5 here. There's a few other parameter study analysis in the project that I don't want to include, so I don't include them. Okay, so once you've collated all these together, you can run off all the analysis, or again, you can simply launch OptiView. Okay, so when you launch OptiView, which I'll just do quickly here, you will now see on the search tab that we have a lot more low cases. Okay, so all the various low cases that come from the 5 parameter study analysis and the variations of tension are all covered here in this list. Okay, so you can see the total number of low cases is 105. So for example, if I only wanted to include the low cases which had 100% current, I could very simply select the current here and unselect everything bar the 100% current. Okay, and now you can see here that it's parsed it down, that there's now only 21 low cases included. Okay, so very quickly, very easily to filter out the low cases so that you're only including the ones that you want to include in your results. Okay, so again, when you switch to the results tab again, you'll see the same information that you had before. You have your custom tab, and then you have these other radio, or custom button, and you have these other radio buttons as well. So what I'm going to do first is I'm going to switch to envelope. Okay, so I'm going to show you how to create an operating envelope. So again, it's very simple. You simply select envelope as the radio button, and then you can select a range of parameters that you want to include in that envelope. So you can include limits for flex joint angles, upper and lower mean and max flex joint angles, von Mises stress, bending stress, whatever it is that you want. Okay, so what I'll do is I'll simply select the mean and max upper and lower flex joint angles and the von Mises stress. Okay, so all of these limits will be considered when creating the operating envelope, and it will use all the low cases that I've selected on the select tab, which is the total number of 105 low cases. Okay, so before you actually generate the plot, there's a couple of parameters you need to set down here. So the first thing is you need to specify what's the limiting criteria. Okay, so you can have a drilling limits and you can have non-drilling limits. Okay, so the next thing I'm going to do after this is I'm going to show you how to define those various limits. Okay, so what I'm going to do is I'm going to select two sets of limits, drilling and non-drilling, and then on my operating envelope plot, I can select my horizontal axis is going to be vessel offset, and on my vertical axis I'm going to set current. Okay, so when I generate that, that's all I really need to do. OptiView will parse those 105 low cases and create an operating envelope for you, something like this. Okay, so you can see your current is on your vertical axis, and your offset is on your horizontal axis. Okay, now again, as I showed you in the previous section, you can really configure this display anywhere you want. For example, if you want to use, so we can see there's two sets of limits here because I've selected drilling and non-drilling. So if I want to specify different colors, say green for drilling and yellow for non-drilling, again, as I did before, it's very straightforward. You can simply select a different plot. So again, you can see the envelope for drilling, and I'm going to change the color here to be green, for example. And if I save it, then you can see my drilling envelope is now green. And simply, if I want to select non-drilling, I can give that another color, maybe something like yellow. And then I can see my non-drilling envelope. Similarly, if I just wanted my drilling envelope, I could just show something like that. Okay. So really what OptiView is doing is it's collating the results from all of these 105 low cases to work out the various points at different offsets and currents. Okay, and again, which parameters it uses will depend on which parameters you select. If you only want to include flex joint angles, again, you'd simply unselect your von Mises stress, or again, there's a range of other parameters that you can include as well. Just in relation to the limits, okay, so that's, if I'm going to just jump back to DeepRiser. So on the parameter study analysis that I've ran before, so again, there was 5 parameter study analysis where I've changed the current. Okay, on each one of these you can select a summary post-processing component. Okay, so this summary post-processing component allows you to specify a range of limits. Okay, so if I just jump very quickly to that, this is the summary post-processing component. I call it Operability Limits. So this is just a component where it allows you to specify a range of different limits that are going to be used by OptiView when it's creating the operating envelope or when it's creating utilization plots. So again, it's very simple. If I click on the first menu here, it allows me to define how many operating limits that I want to include. So there's a maximum of 4. So in this case, I've specified data for drilling and non-drilling. Likewise, I could specify a non-drilling POD or survival limits as well. If you have different naming conventions, it's very you can name those limits anything you want, but these are just the default names, drilling and non-drilling. Okay, so then for example, the riser stresses and bending moment limits, again you get a menu where you can specify a range of limits for the up to 4 different conditions. So again, you can see I've specified data for drilling and non-drilling. So I specified what my minimum riser effective tension should be for both drilling and non-drilling, and a maximum riser von Mises stress. So these are the limits that are going to be used when it's creating the operating envelope. Similarly, say for flex joint limits, you can see here you get the same type of menu. You can specify the limit for mean lower flex joint, maximum lower flex joint, and the same with the upper flex joint. So again, you can see I've only provided data for drilling and non-drilling. That's why there was only 2 options on the OptiView screen. I could just as easily define a third and a fourth. Okay, so that's pretty much it. So what I'm going to do now is I'm just going to switch back to OptiView again. Okay, now I'm going to show you some of these other tabs, which is parameter tabs and utilization tabs. Okay, so again, this is the same general idea as the envelope, except it's just going to create a parameter plot. Okay, so again, on the search criteria, you can say what locations you want to include. So for example, in this case, I'm just going to include one current. Okay, so to make it a bit clearer in terms of what we're actually seeing, I'm just going to reduce the number of locations. So in this case, I'm only selecting my 100% current. Okay, and I'm going to include all my offsets, so I've got a total of 21 locations. So I basically want to create a parameter plot where I look at how a parameter is going to vary as the vessel offsets. Okay, so again, I simply select my parameter option here, and let's say if I want to look at my say maximum lower flex joint angle. Okay, so I simply select that, vessel plot against vessel offset, and I can generate the plot. So again, I immediately get a parameter plot here where it shows me my maximum lower flex joint angle for a range of different offsets. Again, you can see the offsets are plotted in terms of percentage of water depth, going from -10 to 10, and also plotted in terms of actual offsets. So again, if I want to again superimpose, so that's my maximum lower flex joint. If I want to include my maximum upper flex joint, again, I can update the plot, and now I can see both sets of plots. And again, I can parse these as I want. So it's very easy to include different parameters as well. If I want to look at my mean upper and lower flex joints, I can simply add those in as well. And for this is a static analysis of the mean, and the max is pretty much the same. So that's pretty much parameter plots. Now, utilization plots is essentially the same thing, except for a parameter plot, you're seeing the actual angle that's occurring for each locus. So you can see the angle for the lower flex joint angle goes up to about 3.5 degrees with an offset of -10%. As a utilization plot, again, it's just going to plot similar data, but as a percentage of its utilization. So again, it's going to depend now on your limit, whether you're talking about drilling or non-drilling. So again, if I look at my maximum lower flex joint angle, I select my limiting criteria is going to be drilling, and if I generate a plot, then I can see my utilization here. So you can see immediately when the value hits 1, that determines your utilization region there. Okay, so that's your utilization plots. And again, I can add in different parameters very easily if I want to. Okay, so again, you can see the lowest utilization will be is highlighted as well, as you can see in this case. Okay, so that's really it for the utilizations and parameters. As you can see, it's very easy to adjust and configure the different plots depending on what you want to see. It's very easy to use the various options and include different parameters. So again, hopefully you can see it's quite a powerful tool, and it adds another layer of detail to the results that DeepRiser generally creates. Okay, it's a lot more interactive, and it allows you to create type plot report-ready plots that you want to see. Okay. Now, in addition, the reason OptiView is a different module, as in it's launched separately from DeepRiser, is because OptiView can actually be installed remotely. Okay, so if you want to have this capability where you can package up your results and send them to, say, a client or send them offshore, so once you've created your various utilization plots or operability plots, you can save all of this data and package it up and send it to a remote location where OptiView can be installed separately, so separate from DeepRiser, and then the person on the other end can easily open up the results that you've created with DeepRiser and see the same plots that you've just created. And again, it's a very interactive way of viewing results. So again, instead of using a very detailed, say, a WSOC report file that might have hundreds of pages, the user simply opens this OptiView, and then they can parse the information based on what they want to see. So again, if they're only interested in plots of a certain mud weight, they can parse it here like this. If they have a certain wave or current, they can parse the load analysis results to only show the results that's relevant to them at a particular time. Okay, so that's really the power of OptiView as well. In order to do that, it's pretty straightforward within DeepRiser. As I said, you have a WSOC component here where you've grouped together all of the results for that particular well. Okay, so again, if you want to save it, you simply go and export and you can save the database with results. Okay, so what's happening there is that it'll allow you to select any WSOC component that you've got in your project. So in this case, there's only one WSOC component. If I click it here, the analysis will be exported, and it will save a DDZ file, okay, where the results are included. And then OptiView is simply a matter of opening up that DDZ file, and you can view all the same results you've created. Okay, so it's a very easy way to share results from DeepRiser remotely to a remote location. And like as I said, that can be a client's office, and it can be another office somewhere else where DeepRiser isn't installed, or it can be offshore as well.